Hello, thank you for coming, everyone. This is the last presentation of the community tracks. We're really glad you're here. I and some of the other people here today were community leaders. We run the meetups. You are in a large city, chances are there's a meetup, AWS meetup in your neighborhood that you can attend, and if there's not, you could start one. And it's a great way to get a lot of information like the information you're learning here today. You just don't have to wait all year to hear it. So our talk today is on compliance and top security threats in the cloud. And I am Terry Radical. I'm the Director of Security Strategy and Research for WatchGuard Technologies. And I'm really excited to be here because I love sharing security knowledge. And one of the reasons I love to share security knowledge is because I myself was breached before I got into security, and I didn't know what to do. And I told my hosting company about it, and they denied that there was a breach on my web server. And so they weren't really helpful, and I learned a lot through that process. But I've gotten to learn a lot more since then, and I like to share that knowledge. One of the things that I do in my job every day is I look at the news, and I look at the top trends in cybersecurity, and I try to figure out what are the biggest threats that people need to protect themselves from. And some of the things I look at are, what are the major security breaches going on? What type of vulnerabilities are happening, and do they affect our products? Will they affect other people? And what type of tactics are attackers using? There's new tactics, there's old tactics, there's different trends. And so what I'm going to share with you today are some things that I think you should be aware of and look for in your cloud security and try to figure out how you can protect yourself against these threats. So there's a long list of things that you can do for security. Where do you start? Well, first of all, you have to be compliant with whatever laws and regulations apply to your business. And this will differ based on your industry and also your jurisdiction or where you do business. So for example, PCI compliance applies to you if you do anything with credit cards. If you're working with health data, you have to deal with HIPAA compliance. And if you're dealing with PII or personally identifying information, meaning something that identifies me, my name, my address, my phone number, then there are regulations related to that. And there's a big one coming out this year or next year, which is called GDPR. And it's basically for Europe, but it applies to anyone who's dealing with customers in Europe. It means someone can come to you and say, I want you to delete me from all your systems, and you have to be able to do that. But what we know is a lot of the breaches, if not all of them, the companies that are getting breached are compliant. So what does that tell you? Compliance is not enough to be secure and to protect yourself against these breaches. So what do we do next? There's something called a risk-based assessment, and I get this from SANS Institute. They are the largest security training organization in the world, and it's a really good place to learn about security if you want to know more. The risk-based assessment basically says that you look at the things that are most critical to your business. So for example, let's say you're hosting a bunch of images on a website, and there's a vulnerability, and someone could steal those images. Not that big of a deal because those images are already public, right? Let's say you're hosting, I don't know, 43 million social security numbers. Maybe that's something you should start with. I'm talking about the Equifax breach, which is now up to 145.5 million customers affected. So you're going to look at what would be most damaging to your business should it get breached. Secondly, you want to look at the likelihood of something happening, and you want to understand the attack vectors and the way people are going to attack your system, and think about your systems and which are most likely to affect you. For example, if you're running Java and there's Java vulnerabilities, that's something that can affect you. So let's talk about this in relation to cloud. I think everyone should know, if you haven't heard yet, there's a lot of companies getting data stolen from S3 buckets. So this is probably your #1 threat. If you're putting things in S3 buckets, you need to know how to properly secure those buckets. Now, why is this happening? My opinion is that people are going and using the cloud services without understanding how to implement the security controls for those services. So before you use any cloud service, go and read the best practices for that service and how to secure it. The other thing is with S3 buckets, potentially the bucket was secure when it started its life in Amazon, but somewhere along the way there was some sort of incident or some change that caused that configuration to be insecure. So you have to think about not only how you're going to secure it up front, but how you're going to keep that configuration secure. Next, we want to protect keys and credentials. This is another big one that has affected a lot of companies. For example, I think maybe 2 weeks ago, there was a company that put all their keys in their source code. Don't do that. Put your keys in a configuration file or have some other way of managing those keys that's not embedded in your source code. Then what happened is they had a developer who probably didn't know any better, maybe wasn't trained. He took that code and he put it in a GitHub repo, which was public. They had $62,000 worth of resources spun up in their account using those keys. So don't do that. You want to protect your keys. You got to think about when you design your systems, how are you going to make sure that your keys and your credentials are not stolen? The other thing you have to worry about are credentials like passwords. There was an example of a company that took a MySQL database and they put it out and they're just going to put it out there for a minute, just do some testing, and they put it directly on the internet and they had those credentials stolen and that database was breached. So anytime you have credentials or keys, you want to make sure that those are protected. Another example of what not to do with keys is if you have a system that is being built for multiple customers, don't use a single set of credentials for all those customers in your APIs. There was a security company that had a solution where you could submit files to their system and figure out if it was, had some sort of malware or some kind of malicious code in there. And what happened was they had a single set of credentials, keys, key identifiers, whatever you want to call it. It was your access to that API. And they were breached. Or I'm sorry, they weren't breached, but a security researcher got in there and basically figured out that he could use those credentials and he could see everybody's data. And sometimes when you're using these security products, very sensitive data gets submitted with these files. So there were all kinds of sensitive data in there. So when you design your systems for multiple customers, you don't give them one username and password to log into the website. So don't give every customer, every mobile phone, every device, every IoT device a single set of credentials. And again, don't hard code it into your code. So the next thing we need to worry about is broad permissions for your engineers. Now, every developer I know, they want the ability to do anything and everything, and I was one of those people, so I understand that. But the problem is it creates a lot of risk, and why does that create a lot of risk? Well, there's something called the cyber kill chain, and the cyber kill chain means that an attacker their first step is going to be do reconnaissance and figure out what they can breach on your system, and the second thing they're going to do is they're going to probably find some vulnerability that they can use to get into a system, or maybe they're going to do a phishing email to your developer, and they're going to click a link, and their laptop is going to get infected. That laptop that has keys for that developer or credentials for that developer can now do anything in your cloud that developer can do. So if you give developers really broad access, or DevOps people, or administrators really broad access, and they get breached on their laptop, they can do everything they can do, the attacker can do in the cloud. So think about segregation of duties. Don't give one person permission to create IAM roles and to do all the other things that DevOps people do. Then, of course, there's unpatched software. We all know some big breaches probably that were blamed on unpatched software. One of them was Equifax. Another one was WannaCry. WannaCry shut down hospitals and did all kinds of major damage around the world. And WannaCry was SMB vulnerability, and Equifax was a Java vulnerability that had been put out there, patched, but the company didn't apply the patch. This is how attackers are going to get into your environment, so make sure you're patching your software. And it's not always easy, but there are tools to help you do this better. One is GitHub has recently published a way that you can check all your software when it's checked in to tell you there's a vulnerability in that software. And there's also a company called Blackjack Software that does something similar. And 2 years ago at reInvent, I saw a security person from AWS who did an example with a security inspector. And he was checking vulnerabilities as it was going into the build system. So there are tools that can help you do that. Next, you need to worry about malicious software updates. This year, there were some rogue Python libraries that got into the Python repository. And so if developers were not careful, they could either end up at the wrong repository, not the official one, or they could put in a typo when they're trying to download these libraries and get malicious software. And there's some reports that a lot of this software was downloaded and incorporated into applications. Another example was after WannaCry, there was a breach called NotPetya. NotPetya, there was a company called Medoc in Ukraine that published accounting software. And they had an update process, and that company got breached, and everyone who was using that company's software and got updates had malicious software delivered to them. So when you're dealing with software updates, understand your business partner, understand if they have properly secured their environments, and make sure you have a place, things in place to check that your software updates are coming from legitimate sources. For example, if someone's giving you a software update over HTTP, which is unencrypted, it doesn't validate that you're getting to the right server, and there's no checksum, you don't have any idea if what you got downloaded to you is actually the software you wanted, or if it was altered in transit or came from some rogue source. So know where your software is coming from. Open network ports. I have an awesome breach for this one. It happened to someone that I work with, and it's on that list of the risk assessment scale. It's really low, but it's a great example. He set up some software in his own account, like set up a side account, not connected to our corporate network, thank goodness. And he set up the software to try out. It was third-party software. He wanted to see if it was going to work, for our company. And then he kind of left it running, went on to do some other things, came back, opened it up, and there's a nice, pretty ransomware picture right on there. And I was super excited because I just took a reverse engineering malware class. I'm like, oh, give it to me. So I'm looking at this. This happened a week ago. I'm going to write more about it. If you want to find out more about it, you can follow me on Twitter. I'll tell you what I saw and what it looks like. But basically, when I went into the account, what I found was that there were no NACLs. There were no rules of any kind. So it was wide open. Then I went to a security group, and I looked at it, and it had a rule for a certain port, and then right next to that rule was a rule for any. So basically, there was no network rules in the whole account. And if you don't put network rules in your account and you just leave everything wide open, you're asking for trouble. Have you ever put an instance up on AWS and just looked at the traffic that hits it right after you put it up? You will immediately see traffic hitting that instance. There are people all over the world scanning for vulnerabilities and looking for problems. In the case of WannaCry, a lot of people blame the patching, but honestly, it was a SMB vulnerability that affected port 445, or required 445 to be open to the world for that breach to occur. So that port should never be open. There's a list of ports that should never be open, published by SANS. There's these well-known vulnerabilities and things you should never have open to the internet. And any company that would have had port 445 blocked to the internet would not have been affected by that. So some people say, firewalls are useless because there are really tricky things people can do to get through your open ports. But firewalls still have block ports, and if a port is blocked, no one can get through it. So don't leave your network open, and think about how you design your networks to minimize those open ports. The next thing you want to look at is, do you have a flat network? A flat network means basically you have no network segregation. You don't have subnets or different layers that someone has to get through to get to your really sensitive data. Have you ever heard of a 3-tier architecture and you're wondering, why do I have to do all this stuff? It's too complicated. Well, the reason why is because you create layers of security that people have to get through to get to your database, which is typically your goal. It's typically what's most valuable. And so you create these layers and make it harder to get through, and you set up monitoring on those layers. Again, I talked about all the traffic that hits anything connected to the internet. Chances are you'll get breached. You may even be costing you more money because you're getting hit with all this traffic and maybe slowing down your applications. So, set up layers, and if possible, put security appliances between the internet and whatever it is you're trying to protect. There's a number of examples. Obviously, we sell a security appliance that has a lot of things built into it, but there are things like a WAF. Amazon has a WAF that you can protect your website with. And you can use DDoS, you can protect yourself with Shield, and there's a number of different ways you can put some sort of security layer between the internet and whatever it is you're trying to protect. Just like with the developers, you have to think about the permissions that your instances have, and a best practice is to use IAM roles instead of giving keys to those instances. The nice thing about IAM roles is going to rotate those credentials, so your keys, if they get stolen, they'll only be good for a certain amount of time. But in addition, if you give your instances lots of capabilities, then anything those instances can do, any attacker can do who can get on those instances. So again, in the example, some of the other examples we had in the one login breach, developer credentials were stolen and resources were spun up. If you have instances that have permissions to create IAM roles, that's not a good thing because they can go in and create themselves new accounts. If you give an instance ec2.star, that instance can create new networking So think about these things when you're setting up your instances and really try to restrict what you allow them to do. Some of the things they'll do, as I mentioned, they'll create unauthorized resources, and I already gave you a couple examples of that. And another thing they can do is delete assets. There's a company I like to say got deleted in the cloud, and that's CodeSpaces. It's an old story from a few years ago, but basically someone got into their account, they were able to create new accounts and then basically delete everything, and the company ultimately went out of business. Then finally, you want to look out for data exfiltration. The S3 bucket breaches are an example of data exfiltration, but there are a lot trickier ways the attackers get into your data and steal it. For example, in the case of the target breach, which is not a cloud breach, but this could happen anywhere, ICMP packets, which are generally very small, those are ping packets when you ping a server, the attackers put extra information into those packets, and they were able to navigate through the network. Another one I saw recently was DNS being used for data exfiltration. Basically, someone would make a query to a certain type of DNS and get a response that included extra information that would be able to take data out of the network. If you think about DNS, it's basically a proxy between your internal trusted network and your external, untrusted network. So even though you don't have your instances directly connected to the internet, they still have to use DNS and somehow get those name resolutions from the internet. So DNS is something you really want to be careful with. And finally, the Black Swan. I get this from a book. It's called The Black Swan, and basically it talks about faulty logic, meaning just because you haven't seen a black swan doesn't mean one doesn't exist. So you can look at and use your risk assessment with all the things and all the breaches that are happening in the news, but before all these things were public knowledge, and a few years back they weren't as publicly published as they are now, a lot of people thought, well, I've never seen a breach happen to me, so it's not going to happen. Really, a lot of these companies were already breached and they didn't know it. So the Black Swan is about thinking like an attacker. That's a phrase security people like to use, and thinking about how the cloud platform can be leveraged to attack your environment. Just like the cloud is really good for you, AWS has a lot of automation that you can use. That automation can be used by attackers. So you want to think about other types of breaches that may exist. And finally, I like to say that security, really, a lot of it boils down to configuration management. What I mean by this is, in order for someone to get into your environment, there has to be a configuration that allows them to do this. There's two things you can do to protect your configurations. You can look at those configurations at the time of deployment, and that's a good thing because you can block things before they get into your environment. The other thing you can do is scan, and you should do both. Scan your environment in case someone gets in there or someone makes a change after the deployment that puts things in a state that is not secure. And on that note, I'm going to turn it over to Boyan because he's going to tell you more about how you can do that.
Thank you, Terry. Mitigating all those attack vectors which Terry described is actually a lot of work. So it's not one of those things when you basically you go through a small checklist, tick, 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 and I'm done with it, and on to the next thing, I'm secured. It's not that, right? It actually includes and involves a lot of persistence, a lot of training for the engineers and business, and of course, a lot of technology and automation. Very recently, we actually had to go through a big PCI-DSS project at Sixt, and this allows us to do another iteration of our security architecture. And for the remainder of this talk, I basically want to share some of the learnings we had and some of the tools and our approach to security, what we learned, what worked, what didn't. First of all, what is PCI-DSS? How many of you know what this stands for? Okay, just a few. So PCI-DSS stands for Payment Card Industry Data Security Standard. Now, behind this very long name is a fine blueprint with security best practices and controls that an organization that handles payment card data should cover in order to be compliant. The standard is pretty long and extensive. It covers everything from physical access to your servers, who has access to them, how are they managed, all the way to how you build software, what kind of security libraries are in it, what kind of chiffres are you using, how is your network layout looking like, what kind of processes do you have around deploying your software, who has access to your customer and payment data more specifically. All those things are covered in a lot of details. So when we started working on this project, we had obviously, as every project, a quite short deadline. It also comes in two forms, for service providers and for merchants. We actually had to cover both. And what we decided to do was basically use AWS. One thing before we go forward is basically I want to answer a little bit of the question, how does compliance and security relate to each other? Because for a lot of us, they're not the same thing. And the reason for it, the reason why a lot of people say compliance is not equal to security is down to the question about how do you assess compliance. Usually this happens once or a few times a year. Someone comes in your organization and makes sure that all the controls and processes you have are basically matching whatever the standard says. And as I mentioned, this is done once or a few times a year. So unfortunately, in the real world, this is not when attackers are active. They are active every day. New vulnerabilities get discovered and exploited. So in order to be fully secure, you basically have to be on top of this process every single day. What compliance is great for, though, is to set you on this path for security. Because of the wide extent of those standards that you have to cover, you already look into all your processes about how you store this data, about how your system interacts with it, about how the people that work for you have access to it. So to me, personally, if you start on a compliance project, it's actually very good to understand how is the level of security in your organization and to build up on top of it. Now, Terry mentioned something very important. When you start, when you embark on some journey, playing the security for your organization or being also relevant to a compliance, one of the things you have to do is risk assessment. And obviously, you have to go and make sure that the most important and critical parts of your organization are safe. Now, in order to do that, and especially if you're doing it on AWS, what you need to understand, or what we had to also go through, is to understand the fine line of responsibility there, because some people really think that the cloud just covers it all. It covers a lot, but certainly not all. And this is a picture which really showcases the levels of responsibility which a customer has and what AWS covers. To put it very directly, AWS is responsible for the security of the cloud, meaning compute, storage, network, database layers, meaning the data centers and their edge locations, the processes, the employees, everything that is related to that, they cover it for you. On the other side, as customers, we have to take care of the software you write, how this software stores data, what kind of security we use, client, server-side encryption, all those pieces. What kind of operating systems are we running? Are they patched? So obviously, a lot of things. Fortunately, for us as well, as we went on our compliance journey, AWS had a lot of managed services that made our life easier. This is just a subset of them. There are actually more. And all of those are basically ready to be used. So as you can see, you have a lot of building blocks that you can use to, that cover everything from developing software, deploying runtime, and of course, databases, everything you need to build a truly secure environment. Now, I've highlighted a bunch of those services. Those are actually the services that got released on the PCI-DSS certification this year. And by highlighting them, I want to basically have a couple of points. One, you can see that those constitute about 30% from everything that was previously available, meaning that also AWS is taking this pretty seriously, and they're working a lot on that. And two, among those, you're going to see a couple of very interesting ones, namely API Gateway and Lambda. Coupled with everything else that exists, this actually allows you to build complete serverless stacks, which are also compliant. So it reduces the attack vector for attackers. It makes your setup easier. And in the end, you have less things to worry about, less things to manage, less things to secure. So if you can go that way, or if you have a project that you need to start working on, I would really suggest looking at using them because they're there for you. For us, when we started, the first thing was to basically establish our strategy, how we want to approach the problem. And there were three key things that we wanted to achieve, basically. One, we wanted to embed security everywhere in our environment, making sure that yeah, whatever we do, there is as less human interaction as possible and as much automation. And yeah, ultimately, we want to make sure that the environment we have is fully transparent for us. So everything that happens is recorded, monitored, and we can act on it. When we started implementing it, there was one leading concept when it comes to architecture, and it's basically the OODA loop. You guys familiar with that? OODA loop? Okay, very few people. So what this is basically a decision-making process which is very suitable for dynamically changing environments. This concept was actually invented by John Boyd. It was actually Colonel John Boyd, who used to be a fighter pilot for the US military. And based on his experience in participating in different dogfights, he realized that in order to be successful and to basically come on top and survive, you have to go through this process as quickly as possible. It has 4 stages. It goes about observing the environment, detecting what's happening right there. It's about orientation or processing the facts that are happening. Afterwards, you basically have to constitute a decision based on what's happening, what do you need to do. And in the end, of course, you have to act on it. And this is very relevant because if you think about how an attack unfolds, usually it starts by an attacker starting to probe your network, trying to figure out what's going on, and this can be happening also, of course, on the internet. It also can be happening via social engineering in your offices. Afterwards, when weak links are identified, they usually get penetrated, and the goal is to go as far and as deep in your environment as possible so that in the end, intellectual property can be stolen. There are 5, 6 steps in this process. Each of them effectively is applicable to this. Each of them is its own OODA loop. And if you're faster than the attacker to be able to detect what he's trying to do, then obviously you can stop it at the time. Same thing goes the other way around. If he's faster, then obviously breaches happen. Applying this into AWS context and trying to fit the available services there, this is what we came up with for our own understanding. When we talk about observation, we have all those services that collect a lot of data already there. Things like CloudTrail, like AWS config tracking, everything that happens in our AWS environment. CloudWatch, of course, with all the different sensors that it has. AWS Inspector, making sure that we cover all the software running on instances if we have those. So activating all those trails basically constitutes the observation phase. And afterwards, it's about orientation. So making sure that we have the right funnels for all those logs and all those streams of data to go through. It could be as easy as your CloudWatch streams, or it could be your custom Lambda functions, which try to basically aggregate things. Or it could be something more sophisticated, like some, for example, data model, which has a wider spectrum of understanding for attack patterns and can basically classify something. After we classify, it's about to decide what do we want to do with it. For example, if someone is trying to log in very aggressively with an account and constantly hitting the wrong password, maybe someone is trying to brute force a username in our environment. So at this point, it might be a good idea to decide to log this person. So again, in the decision-making process, a lot of managed services that can help. And of course, you can always use Lambda to build your own. And finally, action, right? So when something happens, the actual action of locking someone out, as in the example I mentioned, or notifying that something is going on via an SNS, those are services that can help you. Of course, there are others, such as Shield or WAF, that can do basically decisions on their own in the way to protect you against attacks. Now, having this in mind, let's now look over our architecture and how we basically decided to put all of those things together. The first thing we did was to basically classify our accounts. So centralizing around a security account and making sure that we activate all the trails in the others, which we called the protected accounts, and making sure that all the data is shipped in a central place so that we have a holistic overview of what's going on. This was our first step. And afterwards, if we basically zoom into the security account, what we started doing was classifying that. The first things, of course, our log congestion, all the events that are happening, making sure that we collect them, aggregate them, And the first thing is to store them in S3, enable delete MFA, enable versioning, making sure that this bucket and those events is our archive and it's immutable, and we can always go back there and see what happened if we have to. Of course, we send this data in other places as well, such as in our SIEM system, where, for example, it's checked against known CVEs, against known attack sources, trying to classify if something bad is happening in our environment, and, of course, notifying our security team if something like this happens. We also have operational dashboards for our operators that are monitoring the software and how everything is working. We do the same thing on the AWS side when it comes to configuration of our environments. We basically ingest all of the config changes. We have policies where we check if this is a good thing or not in the end of the day. We also have config rules that do active checks in our environments. Basically, what Terry said again, we always try to evaluate if the configuration that we put in place in the beginning is actually still relative. For example, does all our root accounts still have MFA? Or are all our buckets configured the way we want them to be? And we're going to have an example of that later on. So all those things are happening all the time on a schedule. Of course, when something bad happens, we use SNS to notify our security team, but we don't have only notifications here. Based on the config policies in place and the event policies in place in CloudWatch, we also do a lot of proactive actions. So we basically notify our teams that something bad is happening and immediately try to stop it. For example, if someone goes and shuts down CloudTrail in one of the protected accounts, we know that something bad is on the way of happening. So there is a Lambda function that goes immediately and turns it back on. So things like that. Or if we see that, as I mentioned before, someone is trying to brute force an account, we go back and we lock it. So a lot of things happening on that level. The combination of CloudWatch events and policies and config policies is what we call the controlling core. We call it like that because it basically aggregates all the different policies and controls in terms of security that we have in our account. And this is what we look at when we want to add more or we want to see like what's going on. Coming back to the example of Terry with leaky buckets, I can show you how this looks for us. What we've done is we've enabled a couple of AWS config policies that are protecting for public write and read access. It's actually a very simple thing to do. And what happens next is then AWS config is going through all our accounts, scanning all our buckets, and making sure that they are compliant. AWS config itself is fed by events, and it also goes over schedule so that we can be sure that whenever something bad happens, we can detect it. And when it does, we have a Lambda function in place which gets automatically triggered that goes and fixes the ACL of this bucket. So we know that we can be safe on that side. This solution, which is really 5-minute work, is more than enough to cover this part, coupled with a small policy probably making sure that none of your users can actually upload a document with wide set of permissions. If for whatever reason you cannot do that in your environment, you can extend this solution, for example, by starting to collect all the CloudTrail logs when it comes to putting down files in S3 and defining their ACL. You funnel those through CloudWatch, through CloudWatch events, which in the end sends that to another Lambda function, which will basically make sure that the ACL of each individual file is compliant to your organization best practices. And if not, of course, it fixes it for you. And with a solution like this, if you have it automated, you know that whatever your users are up to, yeah, you can be safe. For our compliance, as we went on our PCI journey, we had to do dozens and dozens of such checks. And I've listed just a couple of them to get you an idea about the wording and how they look like. So we had to solve things like making sure that if we have inactive accounts, they get deactivated in 90 days. And if someone is trying to brute force an account, again, this one gets locked out. There are even things like make sure that this account is locked for at least 30 minutes or until manually unlocked. So a lot and a lot of requirements like this. The biggest challenge for us was, well, if there's so many things we have to build, it's pretty error-prone because this is a lot of code that needs to be written. And one of the things that helped us there was basically this project. It's called AWS config rules. It's open source, and it's a big collection of ready-to-use config rules. It's something that is being done by a large community, and a lot of those checks already have a lot of iterations, which cover a lot of edge cases. So again, even if you're just curious, right, what can be something that helps you, just go have a look. There are dozens of controls that you can use in your environment right away, and it's pretty much plug and play. Building was one side of the problem. The other one was management. So as I mentioned, we had hundreds of those things. And we were wondering, how do we make sure that everything is applied correctly to the different accounts? How can we be selective? What kind of controls go somewhere else? Because we don't only have PCI environments, we also have normal environments from which some of those rules, which might be very important for a specific standard, are getting a little bit on the way of our agility, for example. So we wanted to make sure that we can control what lands where. And one of the projects that helped us here was another AWS Labs open source endeavor, which is called SSAF, which stands for Simple Security Automation Framework. This is really a preview here. The project itself is not open source yet. It's being developed by the AWS Professional Services, the security practice of it. And the guys, what they have been doing is working with a lot of customers, collecting a lot of their experiences and the solutions they're implementing, and basically putting it in a tool to make everyone's life easier. It's going to be open sourced in the next days, so stay tuned. It might be under a different name, but it's one of the things that you should be really looking for if, again, you are embarking on a project like this. The way it works is by using native AWS services such as config, such as CloudWatch, the things we already mentioned, and everything is automated through CloudFormation. It allows you to basically aggregate a lot of different rules and specify for which account what kind of rules you want to have applied. And it's not only applying the rules themselves, you can also configure corrective actions, you can also configure notification policies. So it's basically, you can think of it as a dictionary of all your controls and managing their life cycle. This is pretty much the thing which really speed up our development, and when it's open source in the next few days, basically it will be great if you guys can jump on it, have a look at it, and contribute back, because this is how those tools get better, by having all the community contributing to it. And with this, I guess we would like to thank you. If you have any questions.